The triangle proportionality theorem says that if we draw a line in a triangle, so let's say we draw this line right here, if it's parallel to one of the sides, so let's say it's parallel to this side, and it intersects the other two sides, or it touches the other two sides, then here's what we can say. If we label this line segment A, and this line segment B, and if we label this line segment C, and this line segment D, then the following must be true. A over B must be equal to C over D. And by the way, this line doesn't have to perfectly bisect either side or anything like that. It just needs to be parallel to one of the sides, and it needs to touch the other two sides. So knowing this, let's work through a couple examples of how we can use this theorem to find some missing line segments. All right, let's say we have this triangle right here, and we're told that this line right here is parallel to this side of the triangle. We're also told that this line segment has a length of 2, this line segment has a length of 5, and this line segment has a length of 15. Knowing all of that information, how can we figure out this line segment, which we'll call x? Well, again, according to the triangle proportionality theorem, if we have this line right here that is parallel to one of the sides, and it's touching the other two sides, then the following must be true. 2 over x must be equal to 5 over 15. So to solve for x, we can just cross multiply. So 5 times x is 5x. So we'll say 5x is equal to 2 times 15 is 30. To solve for x, we can divide both sides by 5. These 5's cancel out, and we're left with x is equal to 30 divided by 5 is 6. So x must be equal to 6. All right, let's try one more example. This one's a little different. It says we have this triangle here, and we want to know, is line segment BD parallel to, so these bars indicate parallel, is it parallel to line segment AE? So here's line segment BD, and here's line segment AE. We want to know if these two are parallel. Well, if they are parallel, the triangle proportionality theorem says that the ratio of 12 to 5 should be the same as the ratio of 16 to 7. So if these two ratios are equal, then these two line segments must be parallel. So let's check if that's true. So we'll say, is 12 over 5 equal to 16 over 7? So when we cross multiply these two, we should get the same number if they actually are parallel lines. So 12 times 7, that's 84. So we'll write 84 is equal to 5 times 16, that's 80. So these two values are not equal. So in other words, line segment BD is not parallel to AE. So we'll write no as our final answer. So those were just two different examples of how we could use the triangle proportionality theorem to solve some problems related to triangles.